All right, students, today we are going to be working on 3.5, and you can start with taking notes on page 82. So we're going to start off on page 82. And what we're doing is we're going to put the factoring into practice. So you're going to put the factoring into practice here. So first reminder is if you have something like x squared minus b squared, perfect square minus a perfect square, you get x plus b, x minus b. You're going to use that in most of your problems today, this special perfect square. So just remember that. And in order to be able to recognize these, let's go over our perfect squares. So 4 is 2 squared. 1 is 1 squared. 9 is 3 squared. 4 squared would be 16. 5 squared would be 25. 6 squared would be 36. 7 squared would be 49. 8 squared would be 64. 9 squared would be 81. 10 squared would be 100. So this is your little perfect squares cheat sheet. Perfect squares cheat sheet right here. So what you could do is if you ever see these and it's a 1, a 4, a 9, a 16, 25, 36, 49, if it's any one of these, you'll know, oh, that might fit into my perfect squares. So let's start with, it's going to ask you today to solve the equation. So in order to solve the equation, what you have to do is you have to make it equal to 0 and then solve that equation. So let's look at an example for how to solve an equation. I'm going to write in pen so it pops so we can see it. So let's say we have a problem like v to the third minus 2v squared minus 16v equals negative 32. Say we have that example right there. So the very first thing we need to do is make it equal to 0. So let's pull all this stuff over here. So we're going to add 32 to both sides. I keep my equal sign here. I got a 0. And so I have v to the third minus 2v squared minus 16v plus 32. So there I have my equation. Now, the hint I gave you yesterday was that if you have an equation with 4 terms in it, you're probably going to do factoring by grouping. So we're going to group these. So I remove any common factors in here, which they both have v squared. I'm going to do v squared times v minus 2. And this one, they both have 16 in common, so I'm going to take out a negative 16, and I'm left with v minus 32 divided by 16 is 2 equals 0. So now, we did some of this in the last unit, where when you're solving for zeros, what we're doing is we're finding out where this function crosses the x-axis. So we actually have several places it crosses. Actually, let's finish this grouping. So I have, these are both the same. So I get v squared minus 16, and then I have v minus 2 equals 0. Looks like I'm done, except that, oh, look at this. I have one of my perfect squares, 16. So a perfect square minus a perfect square. So I can factor that out. This one I can't factor out anymore, so I'm just going to write it down. But this one, I get v times v, and it's plus 4 minus 4, right? The square root, the square plus the square, square minus the square. So v plus 4, v minus 4. Now this is all equal to 0. How do I get it equal to 0? Well, if this unit equals 0, v plus 4 equals 0, my whole thing is 0, right? Because 0 times anything is 0. So if this equals 0, or if this equals 0. So I got v equals 4. Oh no, negative 4. V equals negative 4. I have v equals 4. And then I have v equals 2. So there are my answers. V equals negative 4, v equals 4, and v equals 2. So negative 4, 4, 2. Those are my answers. That's where this function crosses my x-axis. Okay? Let's do one more example. Example number 2. Example number 2, we'll say 5w to the third equals 50w. So in order to solve this, I need to get it to equal to 0. So let's take this 50w over here. Now keep in mind, a w and a w cubed are not like terms. So I have 5w cubed minus 50w equals 0. 50w minus 50w is 0. Let's see, let's factor. They both have a w, they both have 5, so I'm going to factor out of 5w. I'm left with w squared minus 10 equals 0. Oh, is that a magic? Oh, shoot. Nope, not a magic number, so that's about as factored as I get. So I have to make my two equations, 5w equals 0 and w minus 10, w squared minus 10 equals 0. So divide by 5, I get w equals 0. And then right here, 10, have w squared equals 10. Now how do I get this to just a w? Square root both sides, and I get w equals plus or minus the square root of 10. So don't forget, when you square root, it has to be a plus or minus, because a negative times negative is a positive, and positive times positive is a positive. So when you square root, you have a plus minus. So w equals plus or minus the square root of 10. All right, those are the three places where this one crosses the x-axis. It crosses at 0, and it crosses at the square root of 10, and it crosses at negative square root of 10. So it crosses at three places. When you have a third here, chances are you're going to have two bumps. 1, 2. If you have, oh, this one is also a third, so chances are you're going to have two bumps. If it's by the fourth, chances are you're going to have three bumps. 1, 2, 3. And I gave you a hint here for the homework tonight. Your ending behaviors are up and up. So it looks something like that. 3, this has two bumps. 4, this will have three bumps. 3, this will have two bumps. Okay, now let's check out a couple of these. So we did some examples. We'll look at this one. We could pull out an r. So we're left with 36r squared minus 1 equals 0. And then if we look at our cheat sheet, look over here at our cheat sheet, we see that 36 is a magic number. So what we have here is a perfect square minus a perfect square. 6r plus 1, 6r minus 1. So there we have our perfect squares. Now where does this cross our 0? Where does this cross our x-axis? Well, r equals 0. And then 6r plus 1 equals 0. And 6r minus 1 equals 0. Minus 1. 6r equals negative 1. Divide by 6. So we get, for this one, sorry, I ran out of room, r equals negative 1/6. And for this one, 6r equals 1. Divide by 6. So I have r equals 1/6. So I have three answers. it crosses the x-axis at 1/6, crosses the x-axis at negative 1/6, and it crosses the x-axis at 0. Let's see what that looks like when we have to graph it out. So let's take, should we do this one since it's got the fourth, x to the fourth? So we're going to factor this one. There's 3 terms here, so chances are I'll be able to factor it like this. Take my 81, get 1, 81, 2, 3. Where's my calculator? 81 divided by 3. Oh, that's 27, right? Yes. 3, 27, 4, 5, 6, 7, 8, 9. Is it 81 divisible by 6? Nope. Oh, well, look, 9 and 9 gives me 18. So I have x squared minus 9 and x squared minus 9 equals my function. X squared minus 9, well, that's a perfect square and a perfect square. So I have, I'll move my equation over here. This is a perfect square, so it's x plus 3, x minus 3. These are perfect squares, x plus 3, x minus 3. So what do I get? If any one of these equals 0, I have my answer. So x plus 3 equals 0. X minus 3 equals 0. X plus 3, well, that's the same equation. That's the same equation. So x equals negative 3 and x equals 3. So it crosses at negative 3 and 3, so I'm going to draw my graph here. Negative 3, 1, 2, 3. Positive 3, 1, 2, 3. And I gave you the hint of the in value. So it goes up and it goes up. So I'm going to say it goes up here, goes up here. And since it's a 4, I'm going to have 1, 2, 3. So I'm going to have 1, 2, 3. So it looks something like this. Now, if we want to see what it really looks like, we could go over here to Desmos calculator. And this equation is x to the fourth plus 18x squared plus 81. And there, in fact, is our equation. Ooh, it goes all the way up to the 80, 81, in fact. So I had mine dropping below, but what we want is the characteristics. So what we have is you have the end behaviors. They both go up. And then you have 1, 2, 3 turns. 1, 2, 3 turns. So that suffices for your graph. All right, there you go. Finish numbers 1 through 10 on page 81. And that is your homework.